Okay, now in the next few pages you're going to be given some exercises to help you work with the areas under the curve for the normal distribution. And you've just been asked to print out in your text the table 1, which is areas under the curve for the normal distribution. Now the first thing I want to point out is that I've arranged these numbers for you. These numbers are readily available online in tables that are constructed in many different ways. For example, in your text here, you see that this table is arranged so that there are actually 8 columns per page. I've given you a table that has only 4 because I thought that format would be easier for you to use when you're just getting used to working with areas under the curve. So let's look at our table. Now, you'll see that, let's see, I have page 3 up here. Let's go to page 1. Okay, so there are 4 columns here. The first column gives you a list of z-scores to 2 decimal places. The second column says larger proportion of the area under the curve. This third column says smaller proportion of the area under the curve. And the last column gives you the proportion of the area under the curve between the mean and z. Now let me just explain quickly how you're going to use this. Let's draw a normal distribution. Remember that we measure the normal distribution in z-score units, right? And let's just put in the mean as a reference point. And of course, when we're using z-scores, the mean is 0, right? Now, any z-score that you come up with will split the normal distribution into 2 portions, right? Now, that's because, if you remember, the normal distribution curve always totals 1. The area under the curve is defined as 1.0. So that means that any given z-score that you find here will demarcate a point on the normal distribution curve and split the normal distribution curve into 2 portions. So let's use 1.0 as our first example. Let's just say we're going to draw this in. This is approximately. So this is a z-score of positive 1.0. And this z-score splits the normal distribution curve into a smaller proportion, which is this proportion, and a larger proportion, which is this proportion. In other words, this distribution will show you the probability of obtaining a z-score of 1.0 or higher in the case of the smaller area, or obtaining the probability of obtaining a z-score less than 1.0. And we can find those probabilities or proportions or percentages, remember they all mean the same thing, by looking at this table and finding 1.0, which is right here. And we see that when we look at 1.0, the smaller proportion of the area under the curve is 0.1587. 0.1587. That's the smaller proportion, right? So this is now the probability of obtaining a z-score of 1.0 or higher, and the larger proportion is 0.8413. That's the probability of obtaining a z-score of less than 1.0. Got it? Okay. Now the third column, proportion between the mean and z, is the proportion that falls between here and here. And for 1.0, you should recognize that proportion. That proportion happens to be 3413, and you've seen that number before, right? So this is a very handy table, and how you can use this will be explained in the coming pages.